Hey everybody, here is day one, or the first part of our review over least common denominator. Least common denominator, up here at the top we have some information, is used to simplify addition or subtraction of fractions. The first time you saw it was in late elementary school to simplify fractions. An LCD, or least common denominator, is the smallest value that all of our denominators could multiply it to make, meaning we need to be able to include every part of every denominator in our least common denominator. What a least common denominator essentially is actually a least common multiple, just in the denominator of a fraction. And the place you would see this most often in real life is when working in electrical engineering. So if you decide to go that way, be ready for the fractions. Up here at the top, we have a review of least common multiple, because that's what we're going to do to find the least common denominator. I'm going to start here first, excuse me, at 6x squared and 8x here. And our goal is trying to find the terms, well, let's say the expression, with the smallest numbers that both of our current quantities will evenly multiply or divide it to. So we have 6x squared and 8x. What I would do is just look at 6 here, and then we have x squared. And this one is 8 and x. Perfect. So I'm going to look at my 6 and my 8. I want to know what is the smallest number they could both multiply to. Obviously, I'm not going to just multiply them 6 times 8. Sometimes that is what's going to happen. But we're going to look for a number that they both multiply into that is smaller than 48. So if I look at 6, 6 times 1 is 6. 6 times 2 is 12, 18, 24. I'm going to stop there because I'm pretty sure 24 is a multiple of 8. So let's check 8. 8 times 1 is 8, 8 times 2 is 16, and 8 times 3 is, oh, I said 3, so I wrote 3, sorry, it's 24. So both of these would multiply to make 24, obviously not by each other, but in general. So that would be the number we would use for our least common multiple. And then looking at our x's here, for this x, we only have one x, and for this one, we have 2. So the least we can have is 2, because we still have to respect what's already here. I could make this into 2 if I just multiplied it by another x. That would give me x squared. So I'm going to go with this one being the least number that we could both have. And that would be the answer. Let's try the next one. This one is a little bit different because we have a monomial and a binomial, just because we have to remember that this is its own factor and it can't be split up like we did for this one. The reason we can't do that is because these are being multiplied and these are being subtracted. Now, when I'm looking for my least common multiple, I'm going to look at the numbers first. I only have one factor that is just a number, so that's actually just going to have to go to the answer, because we could just multiply this one by 2 to get that 2. And then I'm going to look at my x squared, so it's a monomial, a single digit term here. We have x squared. This one doesn't have any that are just x's to be able to multiply by anything, so you'd bring that x squared down. And then lastly, we have this binomial factor. That means we have two terms. This x minus 4, we don't have one over here at all, so you would have to have that x minus 4 as well, like that. If you wanted to remultiply this into its standard form, so to get rid of the parentheses, basically, it would look like this. You're welcome to do that. That is still the same answer. These are equal. But for the rest of the assignment down here, we are not going to do that. We're going to leave it like this, just because that'll help us in the future when we're working through our rational expressions, because we're going to try to cancel out stuff from the top and the bottom. And if it's already factored, it's easier to cancel stuff out. Okay, let's look at this one. Pretty similar to the one up here. We have a 6 and an 8 again, but this time we have a binomial and a monomial. So here I have 6 times 8. 6 times x, not 8. Then I have 8x minus 4. This is its own factor, remember? I'm going to see if I can take anything out of that. Both of those terms can be divided by 4. If I divide those by 4, I would get 2x minus 1 inside those parentheses. So my first term here has 2 factors, 6 and x. My second set here has 2 factors, 4 and 2x minus 1. Put it over here, least common multiple. Now I'm looking at my numbers first. I have a 6 and a 4. I could try just to multiply them. 6 times 4 is 24. that could be possible, but I want the least. The 24 is a common multiple. I want the least common multiple. So there is a number smaller than 24 they'll both multiply into. See if you can think of that in your head before we write it down. 6 would be 6, 12, 18, 24, 30, 36. Those are all the multiples of 6. Multiples of 4. We got 4, 8, 12, 16, 20, 24, etc. You'll notice they both have a common multiple of 12. And that is the smallest one, so that would be the least common multiple is 12. And then I'm going to look at my other monomial term here, so just this guy right here by itself. This is just an x. This one doesn't have any terms that are just x, so we have to include this because all of our factors have to be included in our common multiple. Just going to get brought over here. And then if I look at the next one, I've already taken account of that 4 in my 12 over here. Now I just have this guy. This one doesn't have any binomial factors, so this one's all by itself. It has to be accounted for, so it's going to get brought over here into our answer. And there we go. So again, we can leave it like this. If you want to remultiply, this would make 24x squared minus 12x. But like I said before, we're going to leave it like this for the most part, just so we can practice simplifying when we get to expressions. And then here is our last one. This one, we have two binomials. So we're hoping to find a common binomial when we simplify. We're going to take out our greatest common factor first. So here I have a negative 3x plus 12. I can take out a negative 3. If I divide that, I get x minus 4. And then for this one, I have 4 and 16. I can divide out of 4, and I would get x minus 4. So here are my factors. And I'm going to see what I can get for my least common multiple. I'm going to look at the numbers first. I have a negative and a negative. So they do have a negative. Look at me. They have a negative in common. Now looking at 3 and 4, they multiply together to make 12. And there is no other number that's less than 12 that 4 would divide into. See, here's our multiples of 4. So it is definitely going to be 12. So that takes care of this one and that one. And now we'll look at our binomial one. We have an x minus 4 here and an x minus 4 here. So they have that one in common. So that's definitely going to come over here to our least common multiple. And this is the answer. The reason that we don't put x minus 4 squared is because we're looking for the least common they can have in common, and they already only have one in common. Good. Okay, hopefully that was a good review for you. Now we're going to look down here at the bottom and actually look at it as a common denominator, which means it's going to be looking at the bottom of a fraction. Here I have the steps. Step 1 is to factor the denominator if it's not already factored, just like we practiced with our least common multiple. Step 2, compare the factors of the denominators, and we need to account for the fact that our least common denominator has to have all the factors from all the denominators. And then lastly, determine the LCD by multiplying the factors of the denominators. Like I said, we're going to leave it like this. These are being multiplied. You can see that with the parentheses. We're not actually going to simplify out. We're just going to keep it like that. Once complete, all denominators should have the exact same numbers and exponents of factors. What we're going to do at the end, after we identify this part, is practice seeing what each of these fractions would need to be multiplied by to end up with this as its denominator. So we'll go over this example here and then do number 1, and then you can try number 2. Here we go. Here's our first example. It says find the least common denominator. Step 1, it says try to factor. These are actually already factored. We have x plus 1, 3x, and x squared. If you wanted to split this into 3 times x, you could. If you wanted to split this into x times x, it's kind of splitting hairs, but you could if you wanted to. And then what I'm going to do here is just leave them like this because they're still monomial factors, right? And then determine what our least common denominator is. These are all unique factors. Nothing repeats, and we only have one number in that front. So we already have our 3 here. There's nothing we need to multiply by to see if it's a multiple of 3. So 3 would just come to our answer. That pause was me finding a mistake in these. we'll fix the mistake. I just saw, I've already taught these twice. Okay. Anyways, sorry about that. Here, I am gonna write it. Hold on, let's do this. I think that's my brain didn't like that we didn't do that. Okay, there we go. Here, and okay. Now, here's our factors. The least common denominator. Let's ignore that. We'll start with our 3. Here's our 3. There's nothing else, no other number that needs to be multiplied by. And then we'll look at our other monomial factors. We have an x here and an x squared right there. Remember, we're looking for the least number that we need. So we could multiply them and get x cubed, right? X squared times x is x cubed. But we could have less than that. This one has 2. If I just multiplied this one by another x, it would give me that x squared. So I only need to add one more. So I would just need x squared because that will account for this one as well. And then we still have our x plus 1. So this would be our least common denominator. Sorry about that. This is a good moment for you to see that teachers make mistakes as well. Okay. Okay. So what we're going to do now is the last thing we want to practice doing. This is just kind of getting us a little bit of a leg up for the next time when we get past just doing common denominators, is identify what each fraction needs to multiply by to get it to the least common denominator. Because we have 3 of them, it is kind of weird. Normally you just put them off to the side like this, but because we have a middle one, it makes it kind of weird. So I'm going to do these off to the side. Let me erase some of that. I'm going to do this one off to the side and this one off to the side, and then I'm going to put this one over here. Okay, what I'm doing here, you can see I'm drawing little fractions. I'm going to show you what do we multiply each fraction by to get it to be our least common denominator, to have the right denominator. So if I look at this first one, this one already has x plus 1. Got that right there. So it's missing this part. It doesn't have this part. So it would have to multiply 3x squared times that x plus 1 to make this. But we don't want to actually change the value of our equations or our expressions. We just want to make them have a common denominator. To be able to do that, they have to be the same value as they started with, so we can only really multiply by 1. What we're going to do is multiply the same on the top and the bottom, because I am technically multiplying by 1. Because if you were to work this out, this is 1, because anything divided by itself is 1, right? 3 by 3 is 1, x squared by x squared is 1. So what I'm really doing is multiplying by 1. It doesn't look like 1. Let's try that again with this fraction over here. So this one has an x squared. If I look here, it's missing a 3. And it's missing this x plus 1. And there we go. So again, what we're doing is putting on the top and the bottom. We can't do it on the top without doing it on the bottom because we're only multiplying by an equivalency of 1. Equivalency means the same or equal to 1. And then I put our last fraction down here. We have 5 over 3x. This one I think might be the most tricky in my opinion. It already has the 3. It doesn't have an x squared. It only has 1x. So it's missing an x. And it's missing this x plus 1. There we go. Okay, let's try this one, and then you can try that one. We have another 3 one. If you look at our first one, this is actually not a fraction. It's a whole number. And if you ever have a whole number, it has a denominator of 1. If I look at this one, this has just one factor of 1. This one has a factor of 2. This one has a factor of x. So if I wanted to find my least common denominator, I'm going to account for all those factors. My first one is 1, and this one is a 2. So I'm looking at just the numbers first. I could multiply this to make it a 2. So 2 would be the least common multiple. And then over here, I have an x. These don't have an x. I could just multiply them by x to make it have an x. So we're just missing an x there. So this would be our least common denominator. On this one, again, we have 3 fractions together. It's kind of weird to fit the last one. So I'm going to put this one over here, this one over here, and I'm going to write that x minus 1 over 2 down here. If you wanted to write them all out at the bottom, you could, of course. You don't have to put them all up at the top. So looking at 16x over 1, it has a 1 in the denominator currently. It's missing a 2 and an x. So it's going to get 2x on the top and the bottom. Remember, we're doing this because this is equal to 1. If I divide that, I get 1. So I'm not changing the value of anything. I'm just making it have the same denominator. Looking over at this one, we already have an x. we're missing a 2. And then our x minus 1 over 2, we already have a 2. We're missing an x on this one. And there we go. Good. Go ahead and try number 2 and number 3. I think you could figure out number 3 as well. So try both of those and then come back when you're ready to check it. Back here is number 2. Number 2, we had 2 binomial denominators. Neither of them had anything we could factor out. So we had an x plus 1 and an x minus 1. Remember, to have our least common denominator, we have to include all of our factors. So we have the x plus 1 and the x minus 1. And then over here, I'm just showing you what we're going to multiply by to make our least common denominators. So our first fraction here was missing the x minus 1. And our second fraction was missing the x plus 1. And then number 3 was a little bit trickier. Hopefully you figured that out. Here, we had a 3x squared and a 5x to the 4th. So I went ahead and split them up just because my brain likes it better that way. And I said first my numbers, I have a 3 and a 5. So I want to find the least common multiple. I could multiply them by each other. 3 times 5 is 15. And then I double checked, and that is actually the lowest multiple we could have. Here are my multiples of 3 and 5. So I got a 15 here. And then my x's, these are monomials, so I can just worry about multiplying them. I have 4 x's here and 2 here. I could just multiply this one by x squared, and that would get me x to the 4th. So 4 is the least we could have, right? We could multiply them and get x to the 6th, but we're trying to find the least common that we could do, and we could make this one have a 4. And then over here, I've shown how we're going to do that. Our first one was 3x squared. I wanted to make a 15, so I'm missing a 5. And then I want to make x to the 4th, so I'm missing 2x's, so I got x squared right there. Remember doing on the top and the bottom, because that is equivalency to 1. And then for this guy over here, I have 5x to the 4th. I already have the x to the 4th. I want a 15. I have a 5. 5 times 3 is 15, so I just multiply by 3 over 3. Okay, let's flip the page. We're going to do 4, 5, and 6 on this page this time. And then that's as far as we got for day 1. If you have to come back for day 2 and you don't see it in class, we're doing 7, 8, and 9 on that one. I'm going to have you pause. Well, I'm going to pause. We're going to pause. You can do 4 and 5 right now. You already know how. And then number 6, I just want to talk about because you do have to factor that one. But 4 and 5 are already factored. So go ahead and try to see if you can do 4 and 5, and then come on back when you're ready to check. Here is 4 and 5 if you want to check that you got them correct. On number 4, I think this is the first time that we have one that didn't have to be multiplied, so I want to go over that as well. Our only unique factors were x plus 1 and x minus 3 because this one had both of those already. So this one is actually already our common denominator and didn't need to be multiplied by anything because it already has them both. This one was missing x minus 3, and the middle one, I wrote it down here, was missing x plus 1. And then for number 5, we had a 3 times x minus 1 and a 2x minus 7, both already factored, so we didn't have to do anything there. We just need to multiply all of our unique factors, and that got us here. And then the left one was missing 2x minus 7. Remember, I'm putting on the top and the bottom, because if it happens on the top, it's got to happen on the bottom. And then over here, I was missing 3x minus 1. Oh, sorry, 3 times x minus 1 for both. Cool. Okay, so number 6. Number 6 here, we already have our binomial factors that can't be factored, but then we have this x squared minus 9. We have to factor that to make sure, just like we've been doing, to make sure that we have factors in common or see if we do have them in common or if we don't have them in common. This is a binomial. It's x squared minus 9. Hopefully your brain can recognize that this can be factored because it's a difference of 2 perfect squares. We have previously learned about this back in Unit 2 if you need to go look. Unit 2 is factoring. If I'm not mistaken, it's in the vicinity of the middle of the unit. I think it's in the middle. Maybe towards the end, middle end. So we have x squared minus 9. I'm going to rewrite it as only squared terms because 9 is 3 squared. And then I'm going to split it up. So the way you get this, if you have a difference of 2 squares, its format is going to be a plus b times a minus b, where a and b are the roots of those two numbers. So a would be x, b would be 3, And the only way to get a negative, we get positive times a negative. Now we factor this first one. You'll notice it actually has the two, oh, that was backwards, sorry. It has the two factors that we have over here. So it's actually going to be really similar to number 4 right above it. This would be the least common denominator. So that's all the only unique factors that we have. And this first one wouldn't need to be multiplied by anything because it already has the denominator of the least common denominator. This one over here is missing an x plus 3. And then this middle guy, I'm going to put it down here, is missing an x minus 3. Just a reminder, we're multiplying those because we're always multiplying to get our denominator. And there we go. Perfect. See you later. Bye.